Good morning everyone. Until now we have discussed about what resistance means and the factors affecting resistance and a new concept called as resistivity, which does not depend upon the physical conditions but rather depends on temperature and the nature of the material itself. So we had four category numericals based on that, which we saw in the previous video. So I hope you all have a clear idea regarding what this resistance means. Just have in mind that it's abstraction and it is inversely related to current, and the SI unit of resistance is given as ohm. With these basic information of previous video, we'll carry forward to the upcoming video. Clear? So until now we have taken a wire, stretched it, folded it, cut it. We have done all these things, right? So what we will do after this is like your bridge to go from the basics of electrostatics and electricity to the higher concepts. Clear? And by higher concepts I mean circuits. And if you look up any sort of appliances, there are complex circuits involved in it. How will you able to tear down and study these complex circuits, or how will you build a complex circuits as an engineer in the future? For that you need to know the basics, right? It's like you can't read a Shakespearean novel without knowing what ABCD mean. Similarly, we just basically divide the way you connect a resistor in two ways. Okay, I'm not telling these are the only two ways, but these two ways are standard. You can have combination of these two ways, but these two ways are standard. So if you have resistors, let's say a couple of resistors, you can either, according to textbook right now, you can either connect it in series or you can either connect it in parallel. Clear? In this video you will be focusing mainly on series, and as the name suggests, how do you watch a series? Let's say Stranger Things or Money Heist. How do you watch it? You watch it one after the other, right? Similarly, here also it is connected one after the other, or the other way of remembering or telling that is end to end connection. Clear? Next, in the end what we have is, we can tell that connection as, let's say, resistor 1 connected to resistor 2 connected to resistor 3 and then connected to resistor 4 if I have 4 resistors. And you know guys know the symbol for resistor, it's given as a similar to a zigzag line. If I take this to be resistor 1, I'll have 4 such things connected one after the other. This is how we connect in series. So in today's class I'll divide the session into two major parts. First major part is going for the theory of this connection in series, how it is connected, how to derive it, and the concept behind it. And the next part will go for the simulation. Under simulation we will build our own circuit and verify whether whatever we learned in the theory is working out fine or not. Is it clear? So just take out your copies. Whatever you're learning right now, children, in terms of series is very important. If you are clear about this basics of series, parallel and Ohm's law, you can solve any complex circuits given in this textbook as of now. Clear? Only thing required is your basics of Ohm's law, series connection and the parallel connection. If you know these three basics, you can solve any complex numerical given in your textbook. That will be coming for your board exams. Clear? So first, to understand about series connection, I will build a basic circuit which has three resistors. The first resistor is given here, R1, R2, R3. Okay, so this is resistor 1, resistor 2 and the resistor 3. They are connected in series. I will connect an ammeter to know the value of current, and for potential difference I connect a battery that is also connected in series, 3 batteries, and then maybe we could connect a switch if required. That's it. Okay, and then I'll connect a voltmeter here to measure the potential difference. That's it. Now in this circuit there are three resistors, resistor 1, resistor 2, resistor 3, connected one after the other in the form of a loop. If you take up the current direction is given as positive to negative, right? So it goes in this direction and comes out in this direction. Clear? So when the switch is closed, the first observation we make is what? Under series, the resistors are connected one after the other. Next one, if you see how much path does the current has to flow, do not consider the voltmeter. The current will not flow here. Ideally it should not flow, but minute current will flow. That can't be considered. So imagine the voltmeter is not here. If the voltmeter is not here, how much path does the current has to flow? Trace it. The current has exactly how much path? Only one path to flow. Since the current has exactly only one path to flow, only one path to flow, the current is constant. That's it. So it doesn't matter whether I have ammeter here or whether I have a ammeter here or if I have a ammeter here. It doesn't matter where I have, all the three ammeters will give me the same current reading because current has exactly only one path to flow. Clear? But talking about voltage, I'll erase this ammeter, it's not required for understanding. So talking about voltage, just here, the total voltage is here, that is the positive terminal of the battery, negative terminal of the battery. But if you take up any resistor, none of these resistors are directly connected to the positive terminal and directly connected to the negative terminal. Are they connected? Is any of the resistor connected to the positive and negative of the battery directly? No, right? That means that none of these resistors have the same voltage that we have mentioned here. They will not have the same voltage that we have mentioned there. Is it clear? If you see the first resistor R1, yeah, positive terminal is connected, but the negative is not connected here. Where is it connected? It's connected to the next resistor. Again, that resistor negative is connected where? To the next resistor. Only that resistor is connected to the negative terminal. So none of these resistors, not even the first one, will have the same prescribed voltage. Clear? They will all have different voltages. This is one idea you guys need to remember. That is why we tell that voltage will split or voltage will change. So in this case, since the voltage is changing, we need to analyze how the voltage is changing, right? So in the place of these resistors, I also connect voltmeters to see how they're splitting. So I'll take up the voltmeter 1 here, I'll write it as V1. I'll take voltmeter 2, I'll write it as V2. Then I'll take voltmeter 3, I write it as V3. Okay. Now technically speaking, as I told, V1, V2, V3 will not be equal to V. They must have different values. That is the basic of this approach. So I'll start building an equation stating that total voltage V is equals to V1 plus V2 plus V3. Clear? And what is Ohm's law? Ohm's law is nothing but V is equals to IR. And I know that the current is constant. This V stands for net voltage, am I right? So net voltage will be equal to net current into net resistance. To make it even more understandable, let it as N and N. So net voltage will be equal to net current into net resistance. What do you mean net current? The total current in the circuit and the total resistance of the circuit. Next, what do you mean voltage 1? What is voltage 1? Current I1 into R1. So I'll take I1 R1 plus what is voltage 2? Current I2 into R2. And what is voltage 3? Current I3 into R3. But wait, hold a minute. What do we have? We know that the current is constant. So instead of writing it as I1, I2, I3, I can just replace it as I. So I into Rn is equal to I into R1 plus I into R2 plus I into R3. Clear? Next, I can take the I common out. So it becomes I into Rn is equal to I into R1 plus R2 plus R3. So I and I will cancel out. So what is the remaining term? We just got that Rn is equals to R1 plus R2 plus R3. This is your final statement that you will be writing, final equation that you will be writing to find the resistance, effective resistance when you connect three resistors in series. R1, R2, R3, you just add them. Very simple. If you find the term series, you just have to add all the three. For example, if let's say the R1 value is 2, R2 value is 4, R3 value is 6, what? Ohms. Okay. According to this equation, the net resistance is given as 2 plus 4 plus 6, which is nothing but 12 ohms. As simple as that. Is it clear? And one more thing, what you can find is, I replaced Rn with Rs. There is no compulsion. You can write it on your own. The reason why I am writing it as Rs is resistance are connected in series. Next, what you can find is, the net resistance is greater than the individual greatest, which is the individual greatest resistance, 6 ohms. Am I right? So I can write a statement that always the net resistance is greater than the individual greatest resistance. That's it. Is it clear? This is all about resistance in series where you connect one after the other, and the net resistance given as R1 plus R2 plus R3. Two major takeaways is, you have always current is constant and the voltage will change. Current is constant because you have only one path to flow. Voltage will change because none of these are connected directly to the potential difference. There will be individual potential difference for each one of them. That is a basic equation that you form to derive the resistance in series. And the final statement is, the series resistance, equivalent resistance, is greater than the greatest individual resistance. Now we will apply this logic to solve the value for V1, V2, V3. Clear? So we will just apply this logic. V1, what do you write? I1, R1, right? So V1 is equal to, what is I1? I1 is equal to I2, I2 is equal to I3. Everything is same because current is what? Constant. So can I find V1, V2, V3 without finding I? We can't, right? So first thing you have to find is net resistance, you already found. So the next thing you have to find is net current. What is net current equal to? Net voltage by net resistance. What is the net voltage here, children? Okay, I am not given. Okay, let's take up the net voltage as 24 ohms. I have 3 batteries, 8 volt, 8 volt, 8 volts. What is 3 8s are? 3 8s 24, right? So you have net voltage as 24 and the net resistance as 12 because I want the net current. So the net current is given as 2 amps. So the amount of current passing in the circuit is given as how many amps? 2 amps. Will it ever change anywhere? No matter what, at which point of the circuit you are, the current will always be equal to 2 amps, which is nothing but I1, which is nothing but I2, which is nothing but I3. That's it. Clear? Now I'll apply this logic here. For example, if I want V1, what is V1 equal to? I into R1. What is R1? 2. So 2 2s are 4. 4 volts. That's it. What is V2 equal to? I into R2. R2 is how much? 4. So 2 4s are 8. What is V equal to? I into R3. R3 is what? 6. 2 6 are 12. That's it. Clear? So the voltage here is given as 4 volt and the voltage here is given as 8 volt and the voltage here is given as 12 volt. So the first statement was V1, V2, V3. If I add them and get total voltage is V, right? We'll check it and see. What is 12 plus 8? 12 plus 8 is 20 and 20 plus 4 is 24. Yeah. So you got the 24 voltage, which is nothing but your net voltage. So your sum is satisfying all the conditions. Is it clear? So this understanding of what I've written on this board is very important. It's more than sufficient to solve any question that is based on series. You have to carry forward only the key takeaways from this board. First takeaway is one after the other. Current constant, one path. Voltage will change because none of them are connected. The first equation, total voltage is given as V1 plus V2 plus V3. Net resistance is given as R1 plus R2 plus R3. And then the final resistance is always greater than the individual resistance. Next, how do you solve this total voltage V1, V2, V3? If I want the voltage across the resistor 1, I have to take that current and that resistance. That's it. If I want the voltage across resistor 2, I have to take that current and that resistance. That's it. If I want the voltage across resistor R3, I have to take that current and that resistance. That's it. Clear? The reason is that anywhere the current is not splitting, that is why the current is same. But in some complex circuits, you will be getting series and parallel mixed. There we can't apply directly. But this basic law can be used anywhere you find a series circuit. That's it. So based on this, always keep in mind, if you want V1, you take I into R1. If you want V2, I into R2. If you take V3, I into R3. That's it. And then finally, you can cross check by adding all the three. If you add all the three, you will get the total voltage again, which is 24. And one thing that you can also find here is the same sum can be solved by ratio. The same sum can be solved by ratio. How can you solve the same sum by ratio? For example, we know the total voltage is 24, right? And we know that according to Ohm's law, V is equals to IR. V and R are directly proportional. So, if I want the same current to pass through a greater resistance, my voltage also has to increase. Is it clear? If I have to keep the current constant and if I change the resistance, how will the voltage compensate? It will directly compensate. Clear? Throughout the circuit, my current is what? Constant. So if my current is constant, V is proportional to R. As I increase resistance, voltage has to increase. As I decrease resistance, voltage has to decrease. So it will split in the ratio of 2x plus 4x plus 6x. So 24 is equal to 6 plus 4 is how much? 10. 10 plus 2 is 12. 12x. So x is nothing but 2. Clear? Now apply that x here. So first you got 4. Next you got 8. And next you got 12. Same 4, 8 and 12. Either you can go by the ratio logic or you can go individually, because the ratio logic is again nothing but your initial logic of total voltage is equals to voltage 1 plus voltage 2 plus voltage 3. In terms of writing current as I, you take it as x and write x into 2 plus x into 4 plus x into 6 and find the value for x using that equation. Anything is fine. Either go by the ratio or go by that concept. That is why there is one important interesting aspect. In the same sum, in case if I had the voltage, if the resistance were same, in the same sum, let me assume the resistance as 4 ohms, 4 ohms and 4 ohms. If the resistances were 4 ohm, 4 ohm and 4 ohm, how will the voltage split? Without solving, I can tell you easily. The voltage will split as 8 volts, 8 volts and 8 volts. Why? Because 3 8s are 24. And why it will split as 8, 8 and 8? Because all the resistance are same. Apply the logic and see. Apply the IR logic and see. V is equal to IR. So totally if it is the net resistance will be 4 plus 4 plus 4 will be 12 volts. Again the resistance is what? 12. So if we take up the 24 volt is equal to 4x plus 4x plus 4x. You got 24 is equals to 12x. So x is equals to 2. Again 4 2s are 8. 4 2s are 8. 4 2s are 8. That's it. Is it clear? So once again, what are the key takeaways from this topic? One after the other. Current is constant because only one path. Voltage will change because none of them are connected to the battery directly. Net voltage is given as V1 plus V2 plus V3. Apply that I1 R1 plus I2 R2 plus I3 R3 and finally get the final statement as series resistance equals to R1 plus R2 plus R3, which is greater than the individual resistance. That's it. How will the voltage split? The voltage will split according to the ratio. If the resistance is more, voltage required also is more to maintain the same current. So if you have the equal resistors, voltage will split equally. If I have unequal resistors, voltage will split according to the ratio. That's it. So please stay tuned. Right now I'll be also opening the PHET simulation for working on these same circuits and using voltmeter and ammeter digitally to understand whether whatever conditions we learned here is fitting fine or not. Clear? So have a run through of the notes before we start with the simulations. Thank you.